Question number 11. Two blocks of the same material, A and B, having mass M and 2M. M is for A, material A, 2M is for material B. Material B is 2 times material A in mass, respectively, are supplied with equal amount of heat. It's supplied equal. Then the following alternative: the temperature of both blocks increase equally. B, the change of temperature in block A is twice that of B. C, the change of temperature in block B is twice that of A. D, no temperature change occurs. So let's do this question. We have two materials. One is A, the other is B. So the two material is the same. Is for specific capacity of C of A and specific capacity of CV is the same. For the same material, C of A is equal to C of B. And we use the formula Q is equal to M times C times change in temperature. For A, Q of A, material A is equal to mass C of A, change in temperature of A. For material B, Q of B is equal to mass 2 times A, same material, but the mass is 2 times this one, times C of B times the temperature of B. You know that the same temperature is given for both of them. So we can say that Q of A is equal to Q of B. So heat supplied to them, not the temperature, actually heat supplied to them is for the material A and material B is the same. Therefore, for this one we have MC of A is equal to of B, which is called by C, change in temperature of A, 2 times M mass. This mass is 2 times in case of B. C of B is equal to C multiplied by change in temperature of B. So C cancelled by C, M cancelled by M, and finally we get temperature of A is equal to 2 times temperature of B. So, actually the change in temperature of A is equal to 2 times the change in temperature of B. That means change in temperature of A is, if this one is 20 degrees Celsius, so the other one that the change will be 2 times that one, which is 40 degrees Celsius. So the other way, divide by 2, we'll get half of change in temperature of A is equal to change in temperature of B. This one 2 times mass, therefore we supply the same temperature. The change in temperature become larger for A, for smaller mass, and there is a slow change in temperature for B because of this mass. Mass is 2 times. So the change in temperature is half of A. 1/2 of A will give you, because the mass is 2 times, so the temperature change is half of B. Therefore, let's go back to the question. So it says two blocks of the same material A and B having mass M and 2M respectively are supplied with equal amount of heat. Then A, the temperature of both blocks increase equally. So the temperature of both blocks cannot increase equally. So this is not the answer. B, the change of temperature in block A is twice of that of B. Change in temperature of A twice of the change in temperature of B. So this is correct. C, the change of temperature in block B is twice. No, it's 1/2, not twice. So this is not the answer. No temperature change occurs. There is a temperature in both blocks. So due to the supply of Q, there is a change in temperature. Q is supplied. So there will be a change in temperature. So this is not the answer. So the correct answer is B. Okay. Let's proceed to question number 12. Question number 12. A circular plate of aluminum sheet has cross-sectional area of 400 centimeters square at a temperature of 0 degrees Celsius. What is the area of the plate when its temperature raised to 100 degrees Celsius? So we are looking to the area. So in formula, so we have the following alternative. Now let's do this question. This has A, B, C values. Okay. So in linear expression, L final is equal to L original 1 plus alpha change in temperature. This is for linear expansion. We have original length and we have the change in length from here to here, which is represented by the change in length. That means L final minus L original. Okay, the other one is area. Final area is original area 1 plus 2 times alpha or beta change in T. Or we can write this question area final original 1 plus beta change in temperature. So this area change in both direction, one is above in the y direction and as well as in the x direction. This is called area original and this is the final area. Okay, the last one is regarding the volume. Volume is original volume 1 plus 3 times alpha or gamma change in T. So we can write V is equal to original 1 plus gamma change in temperature. Okay, so for this question we use this formula because we are looking to the area. Therefore, let's look the given value in the question. In the question, we have following value: circular plate circular. It's made of aluminum. It's made of aluminum sheet. Has a cross-sectional area of this one. So area original is 400 centimeter square, and at a temperature of T initial is 0 degrees Celsius. What is the area of the plate when the temperature? Final area is unknown and the final temperature is known, which is 100 degrees Celsius. And alpha is already given, which is 2.3. Alpha is equal to 2.3 times 10 raised to minus 5 per Kelvin. So let's do this question. Let's apply this formula. Original area is given. A is equal to original area 400 centimeter square. 1 plus 2 multiplied by alpha 2.3 times 10 raised to minus 5 per Kelvin and multiplied by change in temperature. Initial, final, the change is 100 multiplied by 100. So A is equal to 400 centimeters square 1 plus multiply this 4.6 multiply this 1 times 10 raised to and minus 5 plus 2 due to this 100. So this area will be 400 centimeters square 1 plus 4.6 times 10 raised to minus 3. Okay, add them together, we will get area is equal to 400 centimeters square. 1 plus this one is 1 plus 0.0046. That is 10 raised to minus 3, and this becomes 0.0046. 4.6 times 10 raised to minus 3. And then it becomes 1.0046. So area is equal to 400 centimeters square multiplied by this number 1.0046, and the result will be area after the multiplication of these two, 40184 centimeters square. So this is the final area after we get a change in temperature from 0 to 100. So the area will change from 400 centimeters square to 401.84 centimeters square. So this is the change in area. So the change in area, actually this is the final area. The change in area is final minus this one. So from the given alternative, let's look the alternative that we have. We have 409, 401, 400. Yeah, this is the answer for 84. So this is the correct answer. 401.8 is the correct 401.8. So this is 4. Not 6, 7, 8, above 5. So this is the answer. Okay, let's go to question number 13. Question number 13. It says which one of the following feature of a wave is correctly described? Correctly described. So the wavelength of a wave is a distance between two successive crests and trough. Let's see first A. A wavelength of a wave is a distance between two successive crests. Let's take sinusoidal wave. So this is the crest, this is another crest, and this is the trough. So between two consecutive crests, we can find the wavelengths, not between this crest and this trough. This is half of the wavelengths, not the wavelengths. So the wavelength is between two consecutive crests or between two consecutive troughs. So between these two, it's possible to get the wavelength, trough with trough. Okay, so a wavelength of a wave is a distance between two successive crests, and trough. 1. B. The amplitude of a wave is the distance between crest and trough. The distance amplitude is between crest and, so the amplitude is actually between this circular in position to this one is represents the amplitude, not between these two. So this is not the answer. C. The wavelength is the maximum displacement of particles from their equilibrium position. No, the wavelength is not the maximum displacement. Amplitude is the maximum displacement of the particle. So this is the definition of amplitude. Amplitude is from the equilibrium. Amplitude is from the equilibrium. This is the equilibrium position to the maximum displacement represents the amplitude. It's not the wavelength. It's the maximum displacement of particle from the equilibrium position. Now the answer. The frequency of a wave is the number of waves. That passes a given point per unit time. That's correct. Full wave means this distance. No, that's not correct. To this distance, this is one full wave. So this is one cycle actually. So the number of cycle, this is one complete cycle. So the number of complete cycles, for example, we may have 100 complete cycles per 10 seconds. So the frequency will be divided 10 hertz will be the answer. Number of 100 cycles. Number of cycles means this one complete and it passes through a given point. Let's say the given point is this one. This is a given point. So this wave, let's say this is a complete cycle, will pass through this wave, this point. So in a given time interval, in that we can count the time, then it's possible to find the frequency. Okay, so when you come to the question, the frequency of a wave is the number of full waves. Not half wave, it's full wave. Full waves that pass through a given point per unit time. So this is correct. That gives you the frequency, which is number of cycles and total time. So that will give you the frequency, number of cycles. 100 cycles means one cycle is represented by full wave. Full wave means cycle, one wave. So that is the correct answer. But this is the wavelength, this is a wave, the distance between crest and trough is not the distance. It is half of the wavelength between this crest and trough. So the correct answer is D. Okay, let's look question number 40. Question number 40. Question number 40. Which one of the following statements explain the nature of longitudinal wave? Still we are in the wave and the nature of longitudinal wave. So before answering this question, let's see the wave, regarding wave. So we have waves. We have two divisions. One is mechanical wave, the other is electromagnetic wave. So these, all the electromagnetic waves, they are transversal, but mechanical wave, they can be transversal and longitudinal. So the difference between transversal and longitudinal, for transversal wave, the direction of propagation, let's say this is the direction of propagation, and the direction of vibration, they are 90 degrees with each other. They will make 90 degrees. That's the nature of transversal wave. Regarding the longitudinal wave, like spring wave, the direction of propagation and vibration, they are parallel to each other. So that's the difference between longitudinal and transversal. So having this in mind, let's look. An example of electromagnetic wave is light. An example of mechanical wave is sound. So question number 40, which one of the following statements explain the nature of longitudinal wave? They are formed when electric and magnetic field oscillate in perpendicular direction. So the electric and magnetic field oscillation is one of the nature of transversal wave. So that is an example of electromagnetic wave. So it's not longitudinal wave. It's not explain the nature of longitudinal wave. When you see the electric and magnetic fields, that is for electromagnetic wave, where electric field and magnetic field oscillate perpendicular to each other. That means the electric field, this is the direction of the electric field if you consider, and this is the direction of the magnetic field. This is for electric field and this is for the magnetic field. So they are perpendicular to each other. They are perpendicular. This is the direction of propagation with the certain v, speed of light in most cases, and vibration is perpendicular to this one. One maybe in the y-axis, the other maybe in the z-axis, and propagation maybe in the x-axis. So electric field in the y and magnetic field oscillates in the z-axis and propagation in the x-axis. So all these are transversal wave. Therefore, A is not the answer. B, they comprise of a series of crest and trough. No, this is for transversal wave, so it is not the answer. They propagate parallel to the vibration of the medium. That's correct. Propagation as well as the vibration, they are parallel to each other. This is the direction of propagation and this is the direction of the vibration. Therefore, C is the correct answer. They are waves that can travel through vacuum. No sound cannot travel through vacuum. So sound is an example of longitudinal wave. Transversal wave can easily travel through vacuum. So this is not the answer as well. So the correct answer is C. Okay. Question number 50. Yeah. Question number 50 says, which one of the following physical quantities is constant in uniform circular motion? That's clear. Speed is constant in uniform circular motion. And B, this is correct. Let's see B. B velocity is not constant because there is a change in direction. So velocity, direction of velocity here, direction of velocity here is different. This one, let's say this is 2, they are different in direction, so it's not constant. Acceleration, the direction of acceleration change, force is also change, so these are not the same. So which one of the following physical quantities constant? Circular motion speed is constant. Question number 16. What is the value of acceleration due to gravity at a height of 1,000 kilometers from the surface of Earth? So there is one common formula that is used for calculating this, and it is g of h can be found g multiplied by r over r plus h, the whole square. So g of h is equal to, you can take the acceleration due to gravity, either 9.8 or it can be 10. So it's given in the first page. So, and we have to take the r value, which is 6,371 kilometer, and r 6,371 kilometer, h at height of 1,000 kilometer, the whole square, and acceleration gh will be equal to 9.8. Use calculator and you get around 0.746, and approximately this result becomes 7.31 meter per second square. So 7.31 is D, so the answer is automatically D. Okay, let's go to question 17. Question 17. Question number 17. What is the rotational kinetic energy of a sphere whose moment of inertia is given? 4 rotating at an angular velocity of 6 per second. So kinetic energy is half, where I is for mass, omega is b. In a linear case, we say kinetic energy is mv square. So mass is represented by this one, and v is for this one. So the kinetic energy is equal to half, as 140 is kilogram, square is I value, and omega is 6 rad per second. And the kinetic energy, this is 7 multiplied by 7, this is square, becomes 36, and multiplied, it will become 2, 5, 2 joule. So C is, B is the correct answer, 2, 5 for question number 70. So what is given here is I value, moment of inertia, and angular velocity. So I omega square give you the kinetic energy. So 40, and this square is 36. I use half, then you get this. Let's look question number 18. 1-8. The region in which an electric charge experiences force from another charge. Let's say we have a positive charge, we have a test charge, let's say small positive test charge. So this positive charge experiences a force, and it shows direction. The force experience direction is represented by this one. That shows the direction of electric field. That shows the direction of electric field. So the region is the electric field region in which an electric charge, maybe this electric charge is a small positive discharge, it experiences certain force due to the other charge, and that is the, so from another charge is so that is electric field. Okay, this is the correct answer. Question number 19. The electric field lines of a positive charge, this is a positive charge, are drawn as shown below in the figure. 2 circles were drawn. This is the first circle, this is the second circle, as shown below, to compare the magnitude of the field strength at point A. This is point A in the second circle, point B in the first circle, and point C in the second circle. And therefore we are going to compare that value. Okay. So question number 90, the electric field lines, positive charge, are drawn as shown below in the figure. 2 circles were drawn. This is the first circle and the second circle. Shown below, compare the magnitude of the electric field strength. Okay. Now let's see. This is a positive charge. So there is electric field which is coming out from it. So the electric field is simply found by using the formula where KQ over R square. Simply KQ, as for getting the R hat value in electric field like this one, just this is a direction indicator. So the electric field is force over Q. So here we have KQ over R square. So it depends on the R value. If R is the same, that is the radius, for example, from this to this, if this is R1, so at each point, if this is A, this is B, this is C, this is D, whatever it is, the electric field the same. The electric field at A, the electric field at B, the electric field at C, the same because they have the same radius. So electric field depends upon the R value. Depends upon the R value. So the magnitude of the electric field. So if you have another circle here, second circle with another radius R2, so the electric field at this point is decreasing due to the change in R value. So the electric field at A and the electric field, let's say A prime. So at electric field at A is greater than electric field at A prime. So this is the smallest radius and this is the largest radius. Okay. So let's see what the question said. Question is, which one of the following statements describes correctly the strength of the electric field at points given? C and D have equal electric field. Let's see the question first. We have A, B, C, and D. So from this, we can say that A, C, D, they are in the same circle, so they have equal electric field. They have equal electric field. And B, so it is in the first circle, so it's not equal to A or D. Therefore, let's see the alternative. For example, describe correct the strength of electric field. Strength only, asks strength only. There is no inclusion of direction at the point given. So we already found it is A, C, and D. They are the same electric field, same strength, but the direction is different. So C and D have equal electric field strengths. That is correct. C and D, they are the same. A and B, no, this is not the same. B is at different circle. B and C, B is also at different circle. B and D is at different circle. So the correct answer is A. The correct answer is A. There is B here, there is B here, another B here. So only C and D and C. We can say A and C, C and D, A and D. So this can be the possible answer for the question. Okay, let's see question number 20.